In this video, we're going to look at forming a recurrence relation based off a contextual scenario. So this is our first scenario. So it's to find the amount in the account after each year when £1,000 is invested at a rate of 4% per annum, which means per year. So this is linking back a bit to GCSE and compound interest. Okay, because if you've got £1,000 initially, let's say I want to find how much is in the account after 1 year, well, then I need to increase by 4%. So I need to multiply by the multiplier for a 4% increase. Now, the 4% increase multiplier would be 1.04. Okay, so a reminder on how you do that. You take your percentage 4, you divide by 100, which is 0.04. And then for an increase multiplier, you would add that value to 1. And then that would give you the 1.04. So that's after 1 year. Then if you want to get the next year, you'd have to times by 1.04 again. And if you want the year after that, you're going to have to times by 1.04 again. So essentially what you're doing, if you're thinking about this as a sequence, is you're taking the first term, which is 1,000, and you're multiplying by 1.04. Then you get the next term, which you also multiply by 1.04, and so on. So let's try and write a statement linking un and un plus 1. So if we have un, which is any term in the sequence, we have to multiply by 1.04, and that is going to give us the next term along in the sequence. So this calculation would be equal to un plus 1, like that. Now, we've completed the main part of the recurrence relation, but we need to also state the first term. So the first term is the £1,000. So what I'm going to write is I'm going to write, instead of writing U1 as the first term, I'm actually going to write U0 as the first term and say that is equal to 1,000. Now, the reason I'm going to use 0 is because the 1,000 is essentially the amount in the account after 0 years. So if you multiply by 1.04 once, you'll get the amount in the account after 1 year, so you'd want that to be U1, so that the time period is linked with the subscripts. Now we're nearly done. There's one other little bit of information that I do technically need to provide and is expected in an exam for you to provide, and that is to say what values of n is our recurrence relation valid for. The first term I can substitute in is U0, so therefore the lowest value of n is 0, and then we can have every positive integer greater than that. So we'll also just state that n must be the same as or greater than 0 to be able to use this recurrence relation. Now, just considering another way we could potentially write this recurrence relation, we could write that un is equal to 1.04 and then un minus 1. So all I've done is subtract 1 of each subscript, so they're still consecutive terms. Now, in this scenario, we wouldn't want n to be 0, because if we put 0 into n minus 1, you're going to get negative 1. Okay, so for this one, we would say that n is the same as or greater than 1 if we were going to write it like that. However, I would go with this top one here. Let's look at a slightly different scenario then. Okay, so have a read of this one. So we need to find the amount in the account after each year when 1,000 is invested at 4% per annum. So that is still the same as last time. Up until this point, nothing's changed. Okay, so I'm just going to write what we got last time. It was un plus 1 is equal to 1.04 un. But then it's saying that £10 is withdrawn at the end of each year. So at the end of a year, you're going to get the 4% interest added, but then you're also going to withdraw £10. So to reflect the withdrawing £10, we need to subtract 10 off the amount in the account every single time. So this would be our recurrence relation, and we'd still call U0 1,000, okay, because that initial amount hasn't changed. And we would also still state that this is valid for n same as greater than 0. Let's have a look at another scenario. So very similar again, there's some slight differences. Okay, we need to find the amount in the account after each month rather than year. The amount invested is the same. The interest rate is the same. Okay, and remember that is a per year interest rate. But our interest is going to be paid monthly. Okay, so therefore we need to figure out if it's a 4% rate per year, how much are they going to get each month? A common mistake is to go to the 4%, okay, and divide it by 12. Now, this is actually not going to be correct, and I'm going to explain why. So we need to find the monthly multiplier, okay? So let's call the monthly multiplier, we'll call it M, okay? And the idea is that's going to be the multiplier for finding the amount in the account after 1 month. Then if I want 2 months, I'm going to have to multiply by M again. If I want 3 months, I'm going to have to multiply by M again. If I want 12 months, then I'd have to multiply by M 12 times. So it would be M to the power of 12. And that M to the power of 12 should be equal to the yearly multiplier, because the 12 represents the full 12 months, 1 year. So M to the power of 12 should be equal to the 1.04, which is our yearly multiplier that we've been using in the question so far. So if you want to find M, the monthly multiplier, we need to 12th root 1.04. So we're going to put that in the calculator, and I get 1.00327, and I'm going to take it to 3 significant figures, which I'll just note there. So then we've got our multiplier. Now what we can do is write our recurrence relation. So you're going to take any term in the sequence. So the first term is going to be 1,000, and you would multiply by this value here to get the amount in the account after 1 month. So it'd be 1.00327, and that would be equal to UN plus 1. The first term in the sequence, which I'm going to call U0 after 0 months, is still 1,000, and would still write that N must be the same as or greater than 0. Okay, let's have a look at another scenario. Okay, once again, we're finding the amount in the account. It's after each year again. The £1,000 is the initial investment again. We've got a 4% as our rate. However, we are now dealing with simple interest. So I'm just going to remind you, how does simple interest work? Well, the idea is you would calculate 4% of £1,000. So 4% of 1,000, okay, which would be £40. And then that is how much you were going to earn every year. So that would be the interest every year. Simple interest does not care about how much is in your account at the end of each given year. It's all about the starting amount. Every year we're going to earn £40. Okay, so to figure out after 1 year, it would be the 1,000 we start with plus 40. Then to get the next year, we'd add another 40, and so on like that. So essentially what we're doing is we're taking any term in the sequence, which we'll call UN, and we're going to add 40 to it to get the next term along. So this is going to be equal to UN plus 1. The other information is going to be the same. So I'm still going to call it U0 as the first term, because the 1,000 is the amount we have after 0 time has elapsed. And the recurrence relation is still going to be valid for n same as greater than 0.